Okay, I'm going to do a couple of versions of 5.2.3a. In this one, if f equals ln of q and q equals t to the fifth, which of the following is closest to the value of df over dt, so the derivative with respect to t, when t equals 2? So I need to find the derivative of f and then plug in a 2. Alright, so this is a composite function. The t to the fifth is inside of the natural log, right? Because q equals t to the fifth. And there's usually a couple ways you can work these. You can either leave them separate and do the derivative of the outside times the derivative of the inside, or you can put them together and then take the derivative like that. In this one, I'm actually going to put it together because it's going to simplify. Right? So watch for one like this and maybe practice a few times. If we simplify it, or actually if we change the way it's written first, we can use one of these rules of logs. These rules of logs were given back in Unit 1. It was where it told you the 3 little rules of logs, I call them. And we're going to be able to use this third rule on this problem. Now in a moment I'll show you one you cannot use the third rule on. Okay, so there's definitely cases where you can use it and cases where you cannot. So let me first rewrite this problem. So I have the t to the fifth inside of the natural log. So I have natural log of t to the fifth. Now according to this third rule of logs, if I have natural log of something to the r, I can pull the r in front. I can pull that power in front. So I did that here. I rewrote f as natural log of t to the fifth equals 5 natural log of t. So that makes this problem super easy because you just need to know that to take the derivative, when you have a constant in front, you have the constant multiple rule, says you can just multiply by that constant, and then you take the derivative of the rest of it. So the 5 just comes down as part of your answer, and then times derivative of natural log of t is 1 over t. So at this point we're done with our derivative, right? I can say that that's 5 over t, if you would rather, but that's all of the calculus of this problem. Okay, next we can plug in the 2. So I want to plug in f. I want to do f prime of 2. I want to plug in t equals 2. So because I could have said this is 5 over 2, or 5 over t, excuse me, we can now just say that's 5 over 2. So super fast on this problem, that's just going to be choice B. Right? Now let's contrast this one with the next one I'd like to show you, which is another 5.2.3a, but this time I'm not going to be able to use that third little rule of logs, because this time I have g is r to the fourth and r is ln of w. So last time the natural log was on the outside. This time the natural log is on the inside. And that's going to mean it's not going to look the same. I'll actually show you how to do this one both ways. You can do it as derivative of outside times derivative of inside, or you can rewrite it with the natural log inside of the fourth power and just do it like a normal chain rule. So let me start by doing the rewriting. So I'm just going to put the natural log in for r, so I have natural log of w to the fourth. Okay, now the chain rule says I start on the outside, so I'll start with the fourth power, and I do that derivative. I leave the inside the same, and then I multiply by the derivative of the inside at the end. So let me do that. I want to do g prime of w is, so I pulled the 4 in front, because the way you do the derivative of something to the fourth is it's 4 times that something to the third. And then I multiply by the derivative of the inside, and the derivative of natural log of w is 1 over w. Okay, now I'm supposed to plug in w equals 1/2. Okay, what is 1 over 1/2? That's the reciprocal of 1/2, right? 1 divided by 1/2 would be 2. So when I go to do w equals 1/2, and I plug in 1/2 for all of the w's, I get 4 times the natural log of 1/2 quantity cubed, then times 2, right? Because 1 over 1/2 was 2. Okay, now that is not listed, right? Not listed. So what I would want to do next is look at natural log of 1/2 and see if I can modify that somehow. Okay, remember our 3 little rules of logs? I had them on the previous page. There was one of them, the second one said if I have a natural log of a fraction, I can make it the natural log of the top minus the natural log of the bottom. So that was what was listed as rule number 2. So let me do that with natural log of 1/2. Natural log of 1/2 would be natural log of 1 minus natural log of 2. Well, the natural log of 1 is 0. So ultimately, out of natural log of 1/2, I just get 0 minus natural log of 2, which is negative natural log of 2. So I can replace the natural log of 1/2 with just negative natural log of 2. So when I do that, I still have the 4 in front, but in place of natural log of 1/2, I put negative natural log 2. That is to the third, and then times 2. All right, 2 times 4 is 8, right? And the reason I moved the negative in front is because negative to the third power, right, would still be negative. So I just moved the negative in front to make it a little less confusing. So I have negative 8 natural log of 2 quantity cubed. And in mathematics, we sometimes will write that third power onto the function. So it's negative 8 natural log cubed of 2, but it means the same thing as negative 8 natural log of 2 quantity cubed. Okay, so if that way made sense and you want to stop, that is fine. On the other hand, if you would like to do it as a different way, the derivative of the outside times the derivative of the inside, I'll show you that as well. So the other way you can do this problem is to just leave them separate. Do the derivative of the outside function, which is the r to the 4th, times the derivative of the inside function, which is the natural log of w. Okay, with that approach, when we do the derivative of r to the 4th times the derivative of natural log of w, we'll have 4r to the 3rd times 1 over w. Okay, it gave me a value to plug in for w, but it did not give me a value to plug in for r. So I have to figure out what I'm plugging in for r. If w is 1/2, when we plug 1/2 into w, we can figure out r is natural log of 1/2. Now earlier, I already proved that natural log of 1/2 is negative natural log of 2, right? So r is negative natural log 2. So now you want to put this 1/2 in for the w, so you'll have 1 over 1/2, and plug in the negative natural log of 2 for the r. And then this kind of shakes out like the last one, like that other explanation. The negative, right, to the third power is going to give you a negative in front. 1 over 1/2 was 2. 4 times 2 is 8. And then that's the same explanation as to why that works out. Okay, so you can work this one out either way, but try to keep up with when you can use that little rule of logs and simplify versus when you cannot. Okay, so when the power is on the outside like this one, I cannot just replace it. But in the last one, the first one I showed you, let me go back to that one. The power was on the inside, and so this first one where I had natural log on the outside and then t to the 5th on the inside, that fit that third little rule of logs. And it's much easier to do this problem if you simplify first. Okay? Practice this one a few times.